CFD stands for Computational Fluid Dynamics. It's a numerical process whereby a model of the structure that's being considered can be built in a computer, and then calculations can be carried out in order to determine what is going to happen in certain scenarios without the need for building, for example, a physical sort of scale model of the building. It works by taking the model that we've constructed and dividing it up into a number of small cells, which can typically run into the millions, and then we can carry out those numerical calculations, and that will tell us what the outcome of that study is. We use it, for example, in smoke control in order to sort of determine for a given scenario what's going to be the outcome of that scenario. Is the system going to be effective at protecting means of escape and providing firefighter access? Generally speaking, we do CFD in order to provide assurance to the stakeholders involved in the project that the system is going to meet the relevant design criteria that it has to achieve. We typically model what we consider to be the worst case scenario, which, for example, in a residential building might be a fire in an apartment where the door to the apartment is directly opposite the stairs, so it's most likely that smoke's going to go up the stairs, or it might be a fire within a particular location within an office. It can demonstrate that the system stops the smoke going up the stairs, or it might demonstrate that it's effective at clearing the corridor within a particular time period so that it meets the criteria that's laid down. It's important to carry out because the results that we get from the CFD are what we use as the basis for the design of the smoke control system. Well, the first thing to appreciate is that CFD modelling can take a long time. Even with the most powerful computers, the prediction of sort of how the smoke is going to behave and how the air and smoke movement through the building sort of can take many weeks. Typically, sort of we tell our customers it takes somewhere in the region of 6 to 10 weeks quite often. Secondly, CFD modelling has to be undertaken by competent individuals. Sort of the more detail that's put into the model and the more accurate that model is, then the more accurate the results are going to be. So it's important that people understand what it is that they're actually putting in there so that the results that they get out are valid. And finally, it's always important to agree the parameters before you actually sort of start doing the CFD modelling. Because if you get agreement on those at the beginning, then it can save you an awful lot of time at a later stage of the project.